This is a review for 5.5 through 5.7. Across from the larger angles are the longer segments. This question asks us to write the sides of triangle ABC from shortest to longest. So we actually start with the smallest angle. Across from that is side BC. The next smallest angle is 46. Across from that is side AC. And finally, the largest angle is 91. Across from that is side AB. So you were supposed to reorder these so that BC was first, AC was second, and AB was last. The same concept in reversed for triangle FGH. If we're going from smallest to largest, we start with the shortest side. Across from that is angle F. So that would be the first one. The next shortest side is angle H across from, the FG, which is 7.1, and the angle across from that is H. So these two should be switched around, and it would be FHG. For question 3, there's two possible scenarios. We have a scenario that 4.5 plus x is bigger than 13.5. In this case, 13.5 is the longest side. And the other possibility is that we have 4.5 plus 13.5 is bigger than x. And here x is the longest side. If I subtract 4.5 from both sides here on the left, I find that x has to be bigger than 9. That's what goes over here. On the right, if I add these two together, I get that x is less than 18. And that's what goes over here on the right. For number 4, I add together the two shortest sides, 6.2 plus 8.1, and I ask myself, is that bigger than 14.2? Turns out these give me 14.3, which is bigger than 14.2, so the answer is yes. So here I substitute 5 in for each of these values, and my sides are 5, 5. Is that bigger than 15 if I add those together? And the answer is no, this is not a possible triangle. For number 6, for some reason the image didn't load here, so I just drew it in. We know that 98 is a bigger angle than 96, which means that side RS is going to be bigger than side PS. So the best choice there was B. For number 7, 35 is bigger than 34. So I look to the angles across from them. And I know that this angle, which we can call ACD or DCA, looks like they're using DCA, is going to be bigger than this other angle over here, which will be BCA. So B is the correct answer. In number 8, I see that 5 is bigger than 4, which means that 5n plus 7 is less than 22. So if I subtract 7 from both sides, I get that 5n is less than 15, or n is less than 3. And that's what goes in this blank over here on the right. The other thing I have to recognize is that 5n plus 7 has to be bigger than 0. So 0 has to be less than 5n plus 7. And if I subtract 7 from both sides, and then I divide by 5, I get that n is greater than negative 7/5, which turns out to be negative 1.4. And that's what I write here. For number 9, these two are very similar, except 98 is bigger than 85 in the same way that 39 has to be bigger than 4n minus 11. So 4n minus 11 is less than 39. If I add 11 to both sides, I get that 4n is less than 50, or n is less than 12.5. This tells me what goes in the second blank, 12.5. And I can also identify that 4n minus 11 has to be bigger than 0. So 4n is bigger than 11, and n is bigger than 11/4. This value turns out to be 2.75, which goes over here. The Pythagorean theorem problems look like this. I take the square root of 2 squared plus 6 squared in a calculator. And if I round this to the nearest tenth, I get 6.3. Number 11 looks a little different because they give me the hypotenuse this time. I can write my answer as the square root of 14 squared minus 8 squared. And if I round this to the nearest tenth, I get 11.5. For this next one, I take the square root of 7.5 squared minus 4.5 squared, and I get a whole number, 6. So remember that Pythagorean triples involve three whole numbers. A squared plus b squared equals c squared, where all three numbers, a, b, and c, are whole numbers. We have 4.5 and 7.5. Are those whole numbers? No, they're not. So this is not a Pythagorean triple. I take the square root of 24 squared plus 32 squared, and the answer turns out to be 40. All three of these values are whole numbers, so yes, this is a Pythagorean triple. First step, I take 9 plus 12 and see, is that bigger than 16? And yes, it is. So yes, it's possible to be a triangle. To classify the triangle, I take 9 squared plus 12 squared, and I figure out the relationship to 16 squared. It turns out it is less than 256. Since a squared plus b squared is less than c squared, we're looking at an obtuse triangle. The next one, 11 plus 14, is that bigger than 27? And the answer is no, it's not. It's not a triangle. I take 1.5 plus 3.6, is that greater than 3.9? And the answer is yes. I take 1.5 squared plus 3.6 squared, and what is that relationship to 3.9 squared? It turns out they are equal to each other. A squared plus b squared is equal to c squared, which means we're looking at a right triangle. I take 2 plus 3.7. Is that bigger than 4.1? The answer is yes, so it is a triangle. 2 squared plus 3.7 squared. What's the relationship between that and 4.1 squared? It turns out, in this case, a squared plus b squared is greater than 16.81, which means we're looking at an acute triangle.